Hello and welcome to my brief tutorial on how to use MakerBot Print to set up some 3D print models. Now this tutorial assumes that you have already created the SolidWorks 3D models or whatever platform you decided to use, and that you have already cleaned up those models so that they are ready to print. And what I mean by that is that not every feature 3D prints nicely. For a lot of times it's bad practice to try to 3D print where you have an overhang, because the 3D printing software does not know how to handle the overhang, so it'll start to bird's nest and stuff like that. And also, this is assuming that any tiny features, like if you have a large model and you have to scale it down, this video assumes that you have already handled that model and prepared it so that it is ready to 3D print at a smaller scale. A lot of the finer details end up getting lost when you have to scale it down. You don't have the same issues when you're scaling up a 3D print, but the 3D print test beds only are so large. So you have to make sure that whatever scale you end up picking, it's going to work with the model that you have. For example, if you have a 1/4 inch hole that you are trying to drill in your piece, and then you're trying to scale it down by a factor of 12, that's going to be a very, very tiny hole. It would be difficult to 3D print it. So just make sure to eliminate any of your finer features if you are planning on scaling it down, and check and make sure that you have all of your overhangs dealt with. You don't have any piece that comes down that starts printing right in the center where there are other pieces around it, because that will also not 3D print very nicely. So with that, let's go ahead and start with MakerBot Print. So we will pop up my MakerBot Print. Now this is the MakerBot Print program. Our facility only has MakerBots because that is the direction that we decided to go. It really works well with MakerBot Print. You can also use Cura. Cura is another software. If you're more familiar with Cura and you feel comfortable exporting with Cura, you can also use that. Eventually, someday, I'll probably come up with a tutorial on Cura. But for today, we're covering MakerBot Print. So here, this is a software that you can get on your own machine. It is a free software. In order to get it, you have to start by going to MakerBot Print Download. I just plugged that into Google, and what you have is download MakerBot Print 3D printing software. It's there is the URL for it if you need that. So feel free to freeze frame and go ahead and write that down. Here they're trying to get you to use Cloud Print. Cloud Print is nice because this is if you have 3D printers that are connected to the web, you can actually plug your model in and go ahead and jump in and 3D print to that. All of the MakerBot printers also have cameras built in them, so you can actually see whether or not there's something on the test bed, see whether or not it's printing, and you can remotely check in and see how your 3D print is doing. Usually because 3D prints take a long time to do, especially if you're doing a large one. We will not be using Cloud Print. We have not connected our 3D printers to the internet. Instead, what I would encourage you to do is download MakerBot Print. Here today, as of today, the latest version is 4.10.1. Download this latest version, go ahead and download it and install it. Rather than have you sit here and watch me install it, I've already got it installed. So here, this is the basic test format for what MakerBot Print looks like. Now, navigation in MakerBot Print is fairly similar to what you would see in AutoCAD or SolidWorks. Here, the right mouse button, if you click it and hold it down, allows you to rotate. In SolidWorks, I believe that is actually, you have to hold down the center mouse wheel button. In order to pan, you hold down the center mouse button. Oh, never mind, that also rotates. No, there we go. I must have right-clicked. In order to pan, you have to hold down the center mouse wheel button, this button here, and just scroll around and that pans. You have your normal left-click actions. To zoom, you scroll your mouse wheel in and out. To me, this is fairly intuitive, but it is what it is. So now that we've covered just how to navigate in this atmosphere, you'll see This is the printing test bed. Now what I would encourage you to do before you set up any model is go ahead and select a printer that you're planning on using. Now for our program we have two different types of printer. We have the MakerBot Replicator Plus and we have the MakerBot Method X printer. They have slightly different test bed sizes, print bed sizes. So you're going to want to make sure that you get whichever one you're planning on using, that you go ahead and set it up specifically for that printer. Now here, because my laptop is not currently connected to the printer, I don't have a USB plug-in that plugs into the printer, and I'm just doing this from my office. I'm going to go ahead and set up a print, and I'm going to take it to the printer using a USB drive. So I'll start with add an unconnected printer. Now here it gives you all of the different MakerBot printer options. Please note that MakerBot Print only works with MakerBot printers, so you have to make sure that you select the right one. Now I said MakerBot Replicator Plus. We have the Replicator 5th Gen. My apologies. So we have the Replicator 5th Gen or the Method X. The nice thing about Method X is that it's slightly more versatile. You can also do different types of materials with it. It has a slightly larger print bed. This is kind of a newer 3D printer. And then we have the Replicator 5th Gen, which is old reliable. We have a lot of print material for this. We also have two of these. I would recommend using the 5th Gen replicator when possible, just because the material is slightly cheaper. And the Method X is a dual support. It tends to be a little bit better for high, more necessarily fine projects. So for this one, I'm going to select the Replicator 5th Gen. And we have export only. It'll show the USB drive. When we go to export this, it will put it to the exporter button. So now with this selected, you'll notice that it's got the red line here. I have that selected, and this test bed will actually, this print bed will size appropriately. So this is only approximately 10 inches by 8.5 inches. You'll have to keep that in mind when you print. You do not want to expand outside of the edges of this, and in fact it will allow you to. So with our printer selected, the next thing we need to do is import our model. So here I'm going to go up here to the project panel. Project panel shows our build plate here. We're working in build plate 1. If you have a project that requires you to have multiple build plates, you can set them all up at once inside of the same project. It's pretty nice. All of your models that you add will show up here, and then all of your build plates down here with the different things that need to be printed can show up down here. I'm going to go ahead and just start with one build plate at a time because I tend to be a little bit more old school. But you could set up an entire project, get every one of those build plates, and save them to a USB drive and do it all at the same time in the same project. Save this. That works pretty well. I will leave that to you. So we'll go ahead and click Start by Add Models. Now you'll notice that I've got a lot of 3D print models that I've downloaded. Thingiverse is a really nice place to be at. But for today, I am going to be going in and 3D printing a vacuum model that I created last year. So in my 3D print folder, I'm going to go down and select. Here are all of my STL files. That's fun. But I don't have to use an STL file in MakerBot Print. So there are a couple of different file formats that are permitted with MakerBot. One of them is the SolidWorks solid part or solid assembly file. You can also use an IGES file. That works as well. STL tends to be the standard for 3D printing. If you're going to use Cura, I believe you have to export to an STL file. Again, that was covered in a previous video. But we can just directly take these and go ahead and make these be our prints. So I'm going to go ahead and select my solid part. Here this was edited to be 3D printable. But you're going to notice that this is larger than my build plate. So the first thing I'm going to have to do is scale it down because it's going to kind of violate what I am trying to do with this 3D printer. It won't allow you to print beyond the outsides of the 3D printer. Funny story. And this is taking forever to load. Thank you, MakerBot Print. So here we go. Here's our model. Now it's going to import this at the orientation that it assumes you are going to want to 3D print at. Now, if I look down here at the bottom, this bottom surface is flat. Now this is a full structure, but this bottom surface is flat. This one has a hole in it. So I would not want to, I wouldn't want to print on this side, because what that means is if it's building from this side out, it's got a hole that it has to build, and that's not very nice for a system to build. I could build it on this face, because this face is pretty flat and it's on the other side of this hole. I think I'm going to go ahead and do that. Otherwise, if you try to 3D print it from this side, you have this big gap in here. You'd probably have to fill that with support material, or else you have this big overhang right there that ends up not working out very well. So I'm going to go ahead and rotate it so that this side is flat. You'll notice that this model now is in our project folder. You'll also notice that the model is very large. So to start out, we're going to go ahead and scale it. Now I just clicked on it to select it. We have all of our modifiers over here on this side. So I'll go ahead and click the scale button to start. You can do uniform scaling, but you can also scale individually on different axes. I don't know why you would, but you can. So if you don't really care about proportions on this, you're just printing some kind of a rectangle and you want it to be thick and whatever, you just want it to look right. You don't have to use uniform scaling. I typically recommend that you do, though. I wonder what happens when you click scale to max. If we just shove it inside of this. Yep. So if you click scale to max, it fits this part to be exactly the right size that it can be 3D printed. Now, if you're trying to print a system of parts that all connect together, I wouldn't recommend using the scale to max. You're going to want to have a uniform scaling that is at some fixed scale for every part. For me, I'm going to go ahead and select 30%, because I know that's going to fit inside of here. Okay, so that's going to be as big as this is. Now I've already checked this part to make sure that it works right. So that's my scaling. My scaling is now done. Next thing I'm going to do is I'm going to do an orientation. Here you've got a couple of different things. You can select 90-degree rotations about different axes. Here, if I look down here, I'll have to hide that for a second. Here are my different axes, so I can rotate about the x-axis, which allows me to flip it up here like that. It's not quite what I want, but it's closer to it. But you can also rotate about y-axis, so here, if I want it to rotate a little bit like that, I could try to manually rotate this so that that face is nice and flat on that surface, but I'm going to end up doing something different. And then you have your Z directional rotation. So let's say I'm going to try to print a few parts on this build plate at a time. I can rotate this so that I can fit other pieces next to it. Here, because this is not flat on the bottom, right here, you want to have a flat surface to print off of. What I'm going to do is I'm going to go ahead and come down here and hit select face to align, and we go ahead and pick this face right there, and it's going to be my bottom face. Okay, and I'll click done. And now what that's done is it said, oh, okay, well, I want that to be flat on the bottom. I'm going to orient this so that that face that I just selected is flat on the bottom. This is one of the really nice features about MakerBot Print. It's really intuitive to use. I really love this software, especially compared to Cura and some other printer softwares that I've dealt with. It's a very, very streamlined service. My only wish is that MakerBot made additions so that you can print using MakerBot Print for other printers. But I suppose they want you to use their software, their hardware. So now that this is in place, I will go ahead and select out of that. Here, this is the move function. Now, Oh, you can't just nicely do that. Okay, so I'm going to go up here and look at the top. Again, scrolling with my right mouse button. And I can go ahead and click on this thing, and I can manually move it, or I can type in positions and neatly arrange this. You can also just grab it and click it. You don't actually have to go into the arrange thing. If you want to be printing it in the center, you can hit center model. Although that did not center it. I don't know what that didn't do what I thought it was going to do. But you can move it that way. This is really nice, but it will move along this plane always. You can move it manually in the Z direction, but you actually have to go to this to do that. I don't see a reason why you would want to move it in the Z direction, because you do not want to lift this off of the build plate, otherwise you're going to need support material. So that's just the basics of how to set up a model so that it is able to be 3D printed. The next thing that I'm going to do is I'm going to go in and check my print settings. Now here we've got the Replicator 5th Gen. This only has one extruder type, so because of that you can only really select either Smart Extruder or Tough Smart Extruder. We have the Smart Extruder on our Replicator 5th Gens. You'll need to check the printer settings on the actual Method X printer if you wanted to use that, because you have to select the appropriate extruders that you will be needed for that material. Here this is just giving you the basics of what absolutely needs to be done. Print mode, you can select you want it to be balanced, which does a really nice job of filling it in so that it's structural. We typically will use balanced for all of our prints. You can also use drafts, which what that will do is it will very quickly print it. You don't get a very good looking 3D print model compared to the balanced, but it's better. And then you can have the min fill, which this is fast, but it has a very small amount of min fill. If you have a part where you don't really care about what the structural integrity is, you can go ahead and use this. It's a really nice feature. For my vacuum piece, I don't actually need this to be structural at all, so the min fill option would actually be the best for mine, so I would go ahead and select that and hit OK. Now for this one, because in theory I like not having to use supports, because supports, they're never fun. But because of that, I don't have the support selected. Otherwise, you can actually go in here and select supports for it. You can go ahead and select breakaway supports, and this can actually show you how the breakaway supports look. It's going to pick every surface that does not have something sticking directly underneath it, and it's going to put a support under it. So here it would put a support down here, and it would put a support over here. And it would probably even put a support in here underneath that lip. That also means you have to go in after the 3D print is done, and you have to clean out that breakaway support. I don't want it, so I'm going to be leaving my support type as none. Now you can also go in here and customize all of the settings, which is kind of interesting. Here I'm in my min fill. That's going to be the first piece. You can actually go into infill and set this as, here's what my speeds are, here's what my infill density is. Because I have it set on the min fill one, it's only going to be printing at 10%. You can print it a smaller percent. 10% it's a nice number. It's something that is workable. I probably wouldn't suggest going below 10. It creates a crosshatch pattern on the inside. Here you can actually select the infill pattern. Some 3D print softwares, their natural selection pattern is just squares. For the MakerBot software, theirs is squares, but they're rotated 45 degrees to make diamonds. But there are some other infill patterns that you can use. The other piece that you would want to use, my computer's being really slow because I'm trying to run this. You can do hexagons. Hexagons would be really strong. Diamond fill fast typically tends to be what a lot of people do. But there are some other kinds of infills you can use too. If you have a feature that needs a particular strength in a certain direction, you may choose a different type of fill. It's more aesthetic than anything, in my opinion. But if it matters to you, you can change that. Here, the floor. This is just a surface that it prints on. You can set this thickness at larger or smaller. If your print is having a hard time sticking to the actual surface, you may want to increase the floor surface thickness. But 0.8 millimeters is pretty standard. Supports and bridging is the other piece that you would need to do. You could have support under bridges. This is where it adds fill material under it. It tends to be breakaway supports. And you can change the density, you can change all of these different features. It's really nice what you can do. I'm not going to get too far into these details because usually you don't want to change them for our systems just because it's not good. But if you needed something changed, this is how you would do it. So I'm going to go ahead and hit done here. Change that density. Now that I've got all my settings selected, I can do one thing where I estimate and do a print preview. Now this tends to be a little bit more computationally heavy and it takes some time, so I am not sure whether or not we're going to sit around and watch the end of this. It depends on how fast it goes. But overall, this is the way that you would create your 3D print model, and this is what it would look like in the software. Now the next piece is you would do an export. What export does is it allows you to send out the G-code file. All 3D printers run off of a software called G-code. It's the same kind of G-code that's used for CNC mills and other CNC projects because it's kind of just become the default code that's used to run these hardwares. G-code, I mean, Cura, MakerBot Print, all of them are going to export a G-code that's going to be sent directly to the machine. Sometimes for smaller pieces that are not very complex, your G-code may be a couple of kilobytes. I have seen fairly complex shapes where the G-code can be several dozens of megabytes. That tends to be a little bit more complex. But you may have something that is fairly complex that requires that, that level of G-code. And all that is it is a solid text file. You can actually go in and edit it and look at it. I wouldn't encourage you to edit it. But that G-code file is read by the machine and is built specifically for the machine so that the machine can read line by line and know exactly how to reproduce the model that you have created. So it's really helpful. It's necessary. But that is the whole purpose of why we have to use this print software, is because it's the conversion between having a 3D model and having a G-code that could actually be used by a machine. So it looks like it's generated the preview. Now what it's going to do is it's actually going to show how this is going to be built using the very, very sparse infill that I have. You'll notice the infill is the yellow. It's being built alongside it. It is really, really light. I might be concerned that it could actually print that. MakerBot seems to think that it can, but that is really light for an infill. And then it's just slowly building layer by layer and showing me how my 3D print is ultimately going to be done. Now I can use this scroll wheel at the side to kind of break it down and look at, like, here is where that bottom surface of that hole cutout is being printed. You only have a little bit of material right there. That's really holding it up. That might be a concern. So maybe my min-fill model is not the best item. Now the nice thing about doing the print preview is it tells you how long it would take. So this would take about 8 hours. I found that the time estimates tend to be really good. they're usually within an hour of when it actually is. So it'll tell you if I started printing right now, it would be done at 10:16 p.m. today. It'll tell you how much weight of your material you're going to need. That's really useful because you need to make sure that the 3D printer has all of that material when it goes to print. Otherwise, you're going to end up with an incomplete print. You're going to have to start all over again. Okay, and then you can just look at all of this. You can even look at the travel moves, how this thing moves around it. So here it would print up to here, move that way, print up. I don't know why it would do that, but that's what it does. I don't always understand these, but I do trust MakerBot Print. It's been a very reliable software. So there we go. That is our print. So here I will hit export to save my gcode file. I'll go back and save it into my folder, the other 3D print files, and this will be my vacuum body print. And here it's saving it as a MakerBot file, but that is a gcode file. If you also print it as a gcode file, that's also acceptable. So there we go. Now we are ready to print this. I will go ahead and move that onto a flash drive, and then I will transport it to the 3D printer, plug it in, and start printing. So this is the basics of how to use MakerBot Print to set up a print. Please note that in order to use the 3D printers in our facility, you do have to be trained in how to use them. It just mostly covers what is and isn't acceptable to 3D print in our facilities, and also covers proper ventilation. Anytime you do 3D printing, you're going to want to have ventilation active. PLA is not nearly as smelly, I guess. It doesn't create as many harmful airborne particulates as would ABS or other types of printing. However, you do still need to have airflow in the room when you're 3D printing, even with PLA. It becomes kind of a health hazard if you don't. When you get trained, it'll talk about airflow. It'll also talk about, for our facilities in particular, if you wanted to print something on your own, how would you pay for it? Who would you talk to? How much would it cost? And that's all information that you can get directly from your print here, and you would work with me specifically to set that up so that you can pay for your print. So make sure to do your training, and if you have been trained, you are free to use our 3D printers. Just please make sure to be the ethical, and if you're going to 3D print something, make sure you pay for it. So, all right, that's the end of this video.